Hello, welcome to a new unit. It's going to be Unit 11, which is called SOLIDS. What solids are three-dimensional figures. So we're not going to just have length and width that we're going to discuss today as like a flat object. Like if we were talking about a rectangle, maybe a circle or a triangle, we're going to give those shapes some sort of height, and we're going to make prisms or maybe a cylinder. Can or so. Um, so a couple things that we're going to encounter with this unit is what's called unit conversion, going from one measure to another. So the first question here, our first three questions on this warm-up are just dealing with unit conversion. So here, number one, convert a speed of 45 miles per hour into feet per second. And how we look at these is as ratios. So we're going to put 45 miles over 1 hour. And we're going to multiply by another ratio so that we eliminate our units here. So I'm going to cancel out the hours first. So we know that 1 hour is equal to its next smallest unit is 60 minutes. Now by putting 1 hour in the numerator with this 1 hour in the denominator, that's going to cancel the hours. So here we'll go 45 miles in so many minutes. Then we're going to cancel out minutes into seconds because we need to change miles, which is in the numerator, per hour to feet per second. So when we put, I'm 60 in the denominator, when we put 1 minute in the numerator, which will cancel our minutes down here, that equals 60 seconds. So minutes cancel with minutes. So we've eliminated hours and converted it down to seconds, but we now need to change miles into feet. And on your math reference sheet, which I'm also going to attach to your notes here today, you'll see some of these conversions. Now the hours to seconds one, you should already know that's not on your reference sheet, but there's 5,280 feet in 1 mile. Now again, the feet had to go in the numerator, the miles in the denominator, because we already had a miles in the numerator. Now as a unit, it's going to cancel the miles into the denominator. So here, the two units we're left over with are feet over seconds. So now we need to kind of multiply throughout. So 45 times 1 times 1 times 5280 equals your 237,600. I'm going to keep that there for a second. Now our denominator is 1 times 60 times 60 times 1. So we know that 60 times 60, let's not forget, is 3,600, and we need to divide those. So we're going to take that, divide by this, symbol. Here we go. And we get the answer of 66 feet per 1 second. So 45 miles per hour converts to 66 feet in 1 second. Sorry, that got a little smushed off the side of the screen. Looking at number 2. 9-time gold medalist Usain Bolt from Jamaica claimed the title of the greatest sprinter in history in the 2016 Olympic Games. In 2009, Usain ran 100 meters in a blazing 32.2 feet per second average speed. How does this compare to a typical driving speed? So again, our typical driving speed is in miles per hour, MPR. I'm sorry, MPH, stands for miles per hour. So we're going to take his 32 feet per second, kind of like the reverse of the first scenario there. So 32.2 feet over 1 second. Now we're going to convert 1 second. I'm sorry, 60 seconds, because we already have the one. 60 seconds versus 1 minute. Ooh. 60 minutes is 1 hour. So now we have hours in our denominator. And the feet has to go into the denominator to cancel the feet already in our numerator. So 1 mile is 5280 feet. So now we've canceled seconds to seconds, minutes to minutes. We've converted from seconds to hours. And feet has canceled with feet, and we're going to end with miles. So in the numerator, we have miles over hours. So multiplying throughout, we have 32.2 times 60 times 60 across our numerator times 1, which we know to be the same answer here. And in our denominator, we just have 1 times 1 times 1 times 5280. So we're going to divide that top answer, the 115,920 divided by 5280, and we get, equals here, is going to be 21.9545. Now here it's saying to the nearest integer, so that's approximately 22 miles per hour that he is running. And looking at number 3, and these conversions again are going to be on your math reference sheet. A local factory has to add the liquid ingredient to make their product at a rate of 13 quarts per every 5 minutes. How many gallons per hour is this? So we have 13 quarts for every 5 minutes. And they want to know how many gallons per hour of the ingredient do they need to add. So here we're going to multiply, and there's conversion on our sheet that we're going to find. That's 1 gallon is 4 quarts. 4 quarts to a gallon. And we need to convert minutes to hours, so we're going to have to multiply by 60 minutes. Cancel minutes, changes to 1 hour. So again, we needed gallons over hours for gallons per hour here. So our minutes would cancel with minutes, quarts cancel with quarts. So that's how you kind of decide what conversion goes on top to bottom. So in our numerator, now we just multiply 13 times 60. We get 780 divided by 20, 5 times 4. So we're going to divide that by 20. And now that'll end us with 39 gallons per hour would need to be added. Okay. So those are some unit conversions just for you to be seeing. I don't know that our homework tonight has any, but it's an important topic for us to kind of bring to the forefront of your attention as we move forward with the unit. So here we have prisms and cylinders we're going to focus on today, and their volume formulas are very simplistic. Okay, so volume of any shape equals capital B times h. And that's, I shouldn't say any shape, volume of any prism. And what a prism is a shape that has two parallel bases. So if you think about a cylinder, there's a circle top and a circle bottom. Those two circles are equal. Okay, so cylinder is like a cup or a can or a jar. Okay, now the curvature of the jar gives you a little error when you're thinking about finding volume of like how much spaghetti sauce you have or so on. Something else, let's think of a box of cereal. We have a rectangular top, a rectangular bottom, and they're connected with those four corners of your cereal box. Okay, but those have parallel bases that are equal to each other. So prisms are shapes that have two parallel bases. Now, cylinder is just a special name for a circular prism, theoretically. We also have triangular prisms. Think about a cake. When you cut a piece of cake, or a piece of pie, it's a really bad sketch, ladies and gents here. Now, a piece of cake is, in a way, a triangle at the top. Now, I know there's a little curve to this, but we're going to kind of flatten that out just for argument's sake right now. So a piece of cake has a triangular top and a triangular bottom. Okay, if you cut it from a big circle cake, which would be a cylinder. So that would be a prism. Um, So we need these area formulas in order to find their volumes. So again, this capital B and capital letters in our formulas are important. They stand for a little bit more than one dimension. So a capital B would be a length and a width kind of multiplied together somehow, some way. And then the third dimension is your height. So volume, we need to know our area formulas first. So area of a triangle, remember, is half base times height. And that's when you have a triangle that has a right angle in it, or you have the base and height being perpendicular. Okay, so we could also use a half AB sine C if we needed it, but in this case, we're going to keep things simple. Everything is going to have a height and a base that are perpendicular to each other. Area of a rectangle is just the base times height. And remember, a rectangle is similar to a parallelogram. You would just need the altitude somewhere within that. Area of a circle is pi r squared. Pi times the radius is r squared. Area of a square is a side squared, because the side is equal, the length and the width would be equal, so you can square them. Area of a parallelogram, remember, is a rectangle, because a rectangle is a parallelogram, is going to be base times height. Circumference of a circle. Now, sometimes they give you the circumference, let's say, of like a tree. So if you think about a tree, a log of some sort, they tell you the circumference of this, you could find the radius to find its area. So circumference is pi times diameter. Remember, a diameter and a radius are in a ratio of 2 to 1. Twice the radius is the diameter. And we're going to look at a couple examples today with those. So a polyhedron is a 3D figure whose surfaces are all polygons. So we're going to have, again, triangular prisms. If you think about a very simplistic tent or fort you could have made, okay? You have a triangle in the front, a triangle in the back, and you can kind of connect them. We have a rectangular prism here. Again, I mentioned the cereal box. I'm just trying to think of things you guys would have in your households right now. A TV screen would be a rectangular prism. It has a very thin width to it these days. But this would be called a triangular prism. And again, I told you a prism has two parallel bases. P-A-R-L-L-E-L. Where in this prism, bases are the front here and the back here. Now, a very simplistic house would have a pentagon up front. You would connect to the roof in the back. So here's, let's say, the roof of a house. Okay. But if we drew a nice little house here with a door, okay, that's considered a prism. It's called a pentagonal prism. Now, if we talk about how many faces these pentagonal prism has, there's a front to your house and a back to your house. I kind of sketch in what the back would look like. So that's two sides, and those are your pentagons. Those are the parallel sides. Then you have 1, 2, 3, 4, 5 sides to your house, right? Two parts to your roof, the left side of your house, right side, and then the bottom that's on the ground or connected to your basement, let's say. So there's 5 other sides. So this pentagonal prism has 7 sides or 7 surfaces total. That would have a special name. It would have a name of a heptahedron. So this suffix, hedron or ahedron, is what you add to the end of a word with the prefix being how many numbers of sides. So hedron is a number of sided figure. So a pentagonal prism, got that one there, sorry. Pentagonal prism has 2 base shapes that are pentagons, but has 7 sides total to it because it has 2 bases plus the 5 sides connecting the front pentagon to the back. A triangular prism has a front and a back, and then 3 sides. So that's going to say the front and back is 2, plus 3 faces, we call them lateral faces. It's going to be 5 sides total, or 5 surfaces, I should say, is made up of that, and that would be a pentahedron. Okay. So a pentahedron has 5 surfaces that make up it as a solid figure. So hedron, again, Hedron. Trying to write with my stylus is a little funky these days. So here we have a rectangular prism. Some box, maybe it's an Amazon box. Okay. But it's 6 units across, 4 units back, and 5 units high. So when we're looking at area of, or volume, I'm sorry, of these shapes, we need to think volume formula equals capital BH. Now, capital B is going to be one of the area formulas from the top of our sheet. Now, this box, I want you to think, let me just take the writing off for a second. When I look at this box, there's a bottom to it. So if I kind of sketch in here, it's really bad sketch. Put that in from this corner, come back down to here, across. Okay. But here we have a rectangle on the bottom. Now it looks like a parallelogram just because of how I'm trying to draw it perspectively for you to see. But that bottom, or let's think of this as a fish tank. Any of you guys have a fish tank at home? It's something else that you could think of. But that bottom, when you start filling it with water, you have one layer kind of hitting the bottom, and then the layers creep up as you fill it with water. So that layer at the bottom has an area of 24, whatever units it is. Let's call this inches and inches just for arguments right now. So 6 inches across, be a very small fish tank. And I don't want to say feet either, but so many units across and so many units back, inches by inches, remember, is 24 inches squared. Okay, that's the area of the bottom. And I'm going to put a capital B here because that capital B again stands for area of base shape. Now, area of the base shape here is a rectangle because all sides are a rectangle. But if I was up on this triangular prism, that base shape would be a triangle because that base shape gets stacked back farther, 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 farther until you hit the back of the prism. Same thing here with the pentagonal prism. This pentagonal face of your house is stacked so many times backwards to get to the back of your house. So capital B is area of whatever the base shape is, and the base shape is how we name them. So you'd have to find the area of this pentagon and multiply it by so many times back. Your height isn't always vertical. I'm going to tell you that right now. Your height, this H, is not always vertical based on how your picture is drawn. Okay, so height is the distance between your bases, if you want to label it like that. It's the distance between bases. So if we were talking about this triangular prism, it'd be the distance from this front piece to this back piece, how far apart they are. Same thing here. That's the height of your. So if you were to kind of rotate those around, you could find it. So in this case, 6 by 4 gets us 24, and then we're going to multiply that 5 times high. So area of the base here, and I can write this just a little bit different for us. Volume equals capital BH. That's our general formula for any prism we encounter. But for our picture, volume is going to equal area of the base, which is our rectangle, times the height. So area of the base we found to be 24, 6 times 4, and the height is 5. So our volume here is going to be 120. And again, I said inches, but that would change depending on the object. So we're just going to write units cubed. So it's going to be to the third power because we multiplied inches by inches, maybe times more inches, or feet by feet by feet. So area, remember the units are squared. Volume, the units are to the third power. Looking at number 2. Find the volume of this triangular prism. So here they tell you that triangle ABC, let's roll back a second. Let me fill in the blanks. This is a triangular prism. So since it's a prism, our volume formula goes volume equals capital BH. Well, since it's a triangular prism, the base shape is a triangle. So this capital B, we need to find area of the triangle. So looking at the triangles here, we have triangle ABC. That's parallel to triangle DEF. And they tell you triangle ABC is equilateral. So we know AB, BC, and AC are equal to EF, D, and FD. They also tell you from B to F is 14 units long. Now that measure is the distance between the two base shapes. So that's our height essentially here. So if you kind of imagine this rotated around so that this bottom went down to the ground and this went up, that could be your vertical height. But your height is not always going to be a measure from bottom to top. Okay. For the prism. Okay, so the height of the prism is a little bit different than the height of this triangle. So if we just focus on the triangle a second, we do need to find that area of that triangle. So if we have triangle ABC, that's equilateral. And we know each side, EF is 6, making DE 6, DF 6, and all three sides here 6 by 6 by 6. We can't find the area of that unless I guess we could say AB, half AB sine C, right? We could say that this angle is 60 degrees. So therefore the area of this triangle would be a half of 6 by 6 by sine of 60, because we know all three angles in there are 60 degrees. Okay. But I'm going to show you a different way, because this is what we're going to need for other questions later, is that this height, when we draw in this altitude from C down to AB, we do break this into two triangles, okay? But these are our 30, 60, 90 right triangles, okay? So we're going to review that here quickly. So in this triangle, again, we have 60 degrees, 30 degrees. Let me just draw this a little nicer, sorry. We have 60 degrees here, 30 degrees up top. Across from the 30-degree angle is the side of 3. Across from your 90-degree angle is the side of 6. So its height is 3 radical 3. So that's that A rad 3 2A scenario. So we are going to use this base of 6, and now our height is going to be 3 rad 3. So area of the base, since it's a triangle, we need to put in a half base times height. Now we have the other height written outside. So the base and height of your triangle are 6 and 3 rad 3. So that's what goes into the middle here for your area of the base, is a half of base 6 times the height 3 rad 3 gets multiplied by our height of 14, is the distance between the bases. So we're essentially finding the area of this triangle and then stacking it 14 times between the front B and the back F. So that's where two heights kind of did come in. We needed the height of the triangle, and we also needed the height of the prism. So typing this all in, now I highly suggest, some of you like to calculate pieces and then multiply by pieces and show me all the work. All we need for these questions is your formula, the substitution, and the answer we'll put in the box here. All we need. So you don't need to take a half of 3 and then multiply it by 3 rad 3 and show me the radicals in the meantime. So once you get to the substitution step, I would start typing straight ahead, straight in. So 1 divided by 2 times 6 times, and I'm going to put some stuff in parentheses on purpose, 3 square roots of 3. Now make sure to come out of your radical there. You have to close your parentheses, times 14. So I have a half times 6 times 3 rad 3, and that gets multiplied by 14. Enter. And we get 218. We get 218.2384. So I'm going to keep the 4 decimals. So 218.2384. So that's if they asked for to the roundest. That's the whole volume in units cubed. But they didn't specify where to round to. Now, something else I wanted to prove to you is that, remember our formula for area of an oblique triangle? Again, we didn't have a base and a height, but I had said to you before, a half times 6 times 6, a half AB sine C times 14 being the whole height of your prism. So here's your area of the triangle times the height, works as well here. So that's if you happen to remember that formula as you're going through. But typically they're going to give you a base and a height that are perpendicular to each other. Now, one other case is if we had to find this in radical form, that's when we would multiply through here. So a half of 6 is 3, gets multiplied by 3 is 9, and 9 times 14 would get us 126 square roots of 3. That's just another version of the answer if they wanted to get fancy on their multiple choice questions, but we're going to stick with either answer here. But for the most part, we're going to have a formula. You're going to make your substitutions, and then you're going to go right into the graphing calculator and find your final answer. Cylinders are a little bit different. This formula is given to you on your reference sheet, but again, the volume equals capital BH works here as well, because your formula says volume equals pi r squared times h. Well, pi r squared is the area of that circle. So when we find the area of the circle, that's pi r squared. And stack that so many times down, that's how we are finding the area. So that times h piece here at the end is representing your height. So this one's working a little bit backwards. So in the question they give you, volume of a right cylinder is 150 pi. So we sometimes treat pi as like a little x variable there, an unknown. The diameter is 10 feet. Find the height of the cylinder. So we know the volume is 150 pi. We know the diameter is 10, which gives us a radius to be 5. The other variable they're asking us for is the height, h, question mark. So when we look at our formula, volume equals pi r squared h. Right now I know the volume, I know the radius, I need to find the height. So our volume substitution, 150 pi goes in on the left side of your equation, equals pi times 5 squared times h. So we're trying to solve for height. So we need to divide over our pi times 25. I'm going to do that mental math in my head. And when I rewrite that to this side here, I'm going to kind of reorganize it because I want the pi to be under the pi and the 25 to be here. So I'm going to use that commutative property to just change the order. So dividing by pi and 25 gets rid of it here so that h stands alone, equals 150 divided by 25 we know is 6. Pi divided by pi cancels. So the height of this cylinder that has 150 pi as its volume would be 6 units. So that's working a little bit backwards through your formula. So again, my suggestion is to write your formula, substitute in what measures they gave you. Now that diameter of 10, we had to kind of convert because g was not one of the variables within our formula here. Number 4. It's going to have a little bit of work going on. The circumference of a tree is 11 feet and its height is 25 feet. Determine the volume of the tree to the nearest cubic yard. So that's in bold. That's going to be important. Nearest cubic yard. They gave us a height. I'm sorry, the circumference of the tree is 11. Its height equals 25. And I'm measurements in feet. But we need to go to yards. So remember there are 3 feet per yard. Okay. And what you're going to want to do is convert to yards before finding your volume. The reason being is volume is a cubed unit. You'd have to cube everything after the fact, or multiply by units cubed at the end. If you convert first, when you do your multiplication through your formula, it does the conversion for you. So what we're going to do here is look at the measures we were given. Now, circumference. So if I look at this log that we're talking about, the circumference of a tree. Here's our tree. There's the rings of the tree. There's the bark. Okay, and you're going to have a circle at the bottom as well. It's the best picture of a log I can do these days. But there's circumference. We have a formula that circumference equals pi times diameter. So in order to go into our volume formula, so we're going to start over here. Volume equals pi r squared h. We're trying to determine the volume. I need a radius and I need the height. So right now I have a height is 3 feet. Now if I needed to convert that to yards, I would divide by 3. So we have 25 thirds yards. It's how tall this would be in yards. But the circumference formula, move that because I kind of forgot. Circumference formula, we know our circumference is 11 feet from here around to here because we can put like a rope around the tree to find the circumference. Typically, you can't measure from one side to the other effectively on a tree. So they do use circumference to measure how wide trees are, what their diameters are. So if 11 equals pi times d, so 11 goes in for your circumference times pi d, we can divide by pi to get our diameter. So this is going to be a decimal value, and we're going to make sure we keep it to 4 decimal places. So 11 divided by pi, and you need to hit second caret to find your pi symbol, we get about 3.5. So the diameter in feet is about 3.5014. Okay. Now something I'm going to show you here is to set up how to convert that to yards. All right, so this again is in feet. So if we took those feet, 3.5014 feet, converts to X amount of yards, and we know 3 feet are in 1 yard. This is a little bit different way to think about how to convert. We can cross multiply and find X times 3, or 3x, equals our 3.5014 and divide by 3. Okay. So if we again have a number of feet, we're dividing that number of feet, which is 3.5 is our diameter, divided by 3 feet per yard, gives us that this diameter is going to be, sorry, I'm going to erase this here because I'm running out of space. So that's the conversion, is if you do feet to yards as feet to yards and look at it as a proportion, you can cross multiply to find out. Because some students get confused on when to divide and when to multiply. Better scenario here is we're making something bigger into a bigger unit. Feet is a small unit into a bigger unit. Yards is going to be division. So we're going to divide again by 3, and we get 1.1671 yards. So converting feet into yards, we just simply here divided by 3. Now, what we have to do is that's our diameter. So we have to divide this by 2 to find our radius. So divided by 2 gets you your radius. So your radius is going to be equal to 0.2917. Now don't round that. So notice next to that 7 there's an 8. We just want the first 4 decimals. If you round this one, it's going to affect the next one, it's going to affect the next one. So we just want to keep those 4 decimals. So that's our radius, it measured in yards, and this is our height measured in yards. So now we're going to substitute. So the final step, volume equals pi times the radius, 0.2917 squared, times our height, 25 divided by 3. Now we know anything divided by 3 is going to end in 0.3 repeating or 0.6 repeating if it doesn't go in evenly. So that's another reason we keep it in a fractional form here, is so that it keeps the most precise measure. So now into the calculator. Now I have the option, since all the calculations I've just done to get my radius is right there, now we can type in everything at once. So we have pi times, now I'm going to try to grab that answer. So I'm going to go up, highlight it, and hit enter. That answer squared. Now notice I open a parenthesis to close a parenthesis. So that's pi radius squared times our height, which is 25 thirds. So I'm going to put in 25 divided by 3. And when we hit enter, we get 2.25 thirds. I got not this answer. Now I just noticed a mistake I made up in my calculations. I divided by 2 times. So when we divided by 3 feet per yard, we got the 1.167. This highlighted answer is what I should have squared. So that's my mistake writing this down. So I'm sorry if I confused you. But 1.16 divided by just 2 should have been the 0.5835. So if I calculate this again, I want to take this answer divided by 2. And now we want to do pi times this 0.5835 squared times our height, 25 over 3. Now should give me the 9.9, 8.9. Yes, that's what we want. 8.9 cubic yards. I'm sorry, I double checked my answer key. I had to pause there. So here we get 8.9152, I'm sorry, 156 cubic yards. Now they wanted to the nearest cubic yard. So this 8.9 will round to 9 cubic yards as a final answer there. Now the next page of notes, we're actually going to skip Cavalieri's principle, okay? We don't need it. I'll fill in the blanks just so you can hear it if you've heard it somewhere else before. If two solids have the same height, and cross-sectional area, they're going to have the same volume. Now that works because volume equals capital H, but here we have a right prism. This one is called an oblique prism because it's not perpendicular to its base. And here's a cylinder. But if this cross-sectional area, so kind of think of this being sliced through the middle, if this cross-sectional area was equal to this cross-sectional area was equal to the area of this circle, and each shape had the same height, equal heights from bottom to top, then they're all going to have the same volume. It's a very simple idea. It's been taken out of our curriculum into our next gen standard. So we're going to skip 5 and 6 as part of your notes. I'm going to go to the back page, number 7. And this is more of another application question. Tracy has two empty cube-shaped containers with sides of 5 inches and 7 inches, as shown in the accompanying diagram. So we have one cube that measures 5 by 5 by 5 and another measuring 7 by 7 by 7. So when they tell you cube, it means equal-sided. So it's going to be all squares. She fills the smaller container completely with water, then pours the water from the smaller container into the larger container. How deep to the nearest tenth of an inch will the water be on the new container? So what we're going to look at here is that this is getting filled up completely. So it's 5 by 5 by 5. So the volume is going to equal area of the base times the height. So area of this base is 5 by 5 is going to be 25. It's multiplied by 5 high. So cube, meaning 5 by 5 by 5, right? So the volume of the smaller container is 125 inches cubed. Now, that volume, all of that water here, okay, is going to fill into this shape here. Now, when it goes into the new shape, or into the new container, it takes on a new shape. So we know that the water level isn't going to be completely full. It's going to take on its new container and it's going to fill the bottom up to so much height. So the volume of the second container is area of the base times the height. Well, the volume of water we're putting in is 125. So we're using the volume from the first shape, 125, to be put in. Now, area of the new base is 7 by 7. So every time you pour a little bit of that water in, it makes like a rectangular shape at the bottom of your container, and that goes up so high. So our volume stays as 125 because that's how much water we're putting into it. And the new base is 49 times the height. So now when we take 125 and divide by 49, we get our new height to be, so again, 125 divided by 49 is going to give us a new height of 2.55. Now to the nearest tenth is going to be 2.6 inches high. The pizza strap question I'm also going to skip for now. I might come back to that a little bit later if you wanted to try it on your own. I'll get you at least to the answer for part B, would have been 254 inches cubed. So if you wanted to try that, it's talking about a pizza, which you can assume to be a cylinder. They tell you the volume of the box is 324. And they're asking to find the volume of just the pizza here. So in the first case, X would be 18 as well, which you kind of need for your next question. So if you wanted to try this, those are your two answers. Going down the third part, I don't have that down right now, so I can't help. But I'm going to give you a couple hints for the homework. So this geometry H classwork is really your homework assignment. There are 6 questions here. And a couple of them are a little bit different than what we would have just done. So looking back at number 1. Remember, a farmer has 64 feet of fence to enclose a rectangular vegetable garden. When we're talking about a rectangular vegetable garden and fencing, that's going to be your perimeter. Okay? Which dimensions would result in the biggest area of the garden? If the length and width are equal, if the length is 4 more than the width, and so on. But when we're looking at perimeter, and it's 64 feet worth of fencing, if that's a square case, and that's a really bad sketch of a square, but if it was a square one, the length and width would be equal. So 64 divided by 4 equal sides would give you dimensions of 16 by 16. So you kind of would go through the case like that. If this one was 4 more than the other, you could find which one would have the bigger area. Kind of obvious when you think about it. So I want to give you guys an opportunity to read it, reread it, and think about it. A solid metal prism has a rectangular base with 4 inches by 4 inches and a height of, the base is 4 inches by 6 inches and a height of 4 inches. So this could be considered a square prism if you focus on the square front or the rectangular bottom. So depending on how you look at it, it could be considered a different shape, but length times width times height is what you really have to assume with anything that has square and rectangular sides. A hole in the shape of a cylinder with a radius of 1 inch is drilled through the entire length of the prism. So here, if you have like a wooden block and you needed to drill through it, like the leg of a table or some kind of furniture, an end table of some sort, okay, you need to drill through the center to have that support piece or the whatever you need there. So in this case, you're going to find volume of the prism, which will be your area of the base times the height. Okay. And then you're going to subtract volume of your cylinder, which is pi r squared. Now again, I highly suggest taking your formula, making your substitutions. So area of the base is 4 by 6 by a height of 4. Here, you know your dimensions. Radius is 1, and the height of that cylinder is from here back to here would be 6 as well. And I would just type it all in at once. So I'd make all your substitutions here and then type that whole line into your calculator to find a final answer. Sometimes you make a typing error or you write something down incorrectly. I would make formula, substitution, and answer. Number 3, you're going to have to convert to gallons. Now here, this conversion factor is going to be used after. There are 231 cubic inches per 1 liquid gallon. So what you're going to do is you're going to find your volume equals so many inches cubed. Okay. And this conversion 231 cubic inches is in 1 liquid gallon. So you're going to take your final answer there and you're going to end up dividing. And then divide by 231, and that's going to give your volume in so many gallons. Because again, we're going to something bigger. We have a small unit. To get to a bigger unit, we do have to divide. I know it seems a little bit backwards. So those are the hints I have for your homework. Try the best you can. Let me know if you need any help via email. We can set up a Google Meet. Thank you. Have a good day.